Hi, so good afternoon, everyone. Welcome to our subject, SRQ, Design of Steel Structures. And for today, we will be continuing our discussion, bolted connection pa din, but focusing now on two types of loading that is acting simultaneously dun sa connection natin. So last time we discussed yung isa dun sa design ng o yung type ng bearing type ng connection ng bolt connection natin, which is yung slip critical connection. And from that, we have discussed how to consider yung effect ng pag-slip critical or kapag yung friction between our plates, what's na snag-tighten natin sila, kung ano yung magiging capacity ng section natin and how we design yung number ng bolts na pwede natin i-provide for our structure. And we have witnessed na if we are considering a slip critical connection, always or most of the time, twice lagi yung number ng bolts in comparison with a bearing type connection. Kasi nga, uh, ang kino-consider niya is to attain yung snug tight condition natin na para ma-attain yun, kailangan may specific na number ng bolts na produce ng enough friction to provide capacity or slip capacity dun sa mismong connection natin. Okay? So, for our midterm examination, uh, I decided na hanggang dito lang sa combined loadings yung i-consider natin. Okay? And what do we mean by combined loadings? Okay? So, when bolts are subjected to combined loading, meaning they experience more than one type of loading, or may applied load tayo dun sa mismong connection natin na more than one, no? So, it means meron tayong combined loading. So, these loads would include tension, compression, shear, and also movement. So far, lagi yung mga consider natin, laging uh, so far yung sa bolt shear capacity, di ba? Then bolt bearing, and then wala pa tayong kino-consider for tension and for moment. So, yung sa moment, we will not discuss today yung sa moment kasi that is for loadings na eccentric dun sa mismong connection natin. But we will consider the combination of a tension load and a shear load na pwedeng
Ilan yun nandun?
ma-appear o pwedeng maging present sa
46.
structure natin. Okay? So, engineers need to ensure na yung bolts natin can withstand yung various loading natin without failure. And an example of that is this one. No? So, as you can see here, meron tayo ditong beam dito. And then may nakakonect sa kanya dito sa ilalim. So, kung halimbawa may bracing siya dito or meron pang tension member na naka-incline, makikita mo, yung mismong loading mo is along siya dun sa length ng tension member natin. And when we try to analyze yung mismong connection of that member, yung cassette plate natin, together with the beam that we are trying to connect yung mismong tension member, pwede natin kunin yung component ng concentric force na yun. And mangyayari, it will be applied as a shear and a tension force dun sa mismong bolt connection natin. So, doon natin pwede i-consider yung effect nung pagkakameron ng combined loading natin. Okay? So, since we are talking about two types of loading, which is yung tension and shear nga, so babalik tayo dun sa napag-aralan natin before. No? So, before meron tayong bolt shear capacity. And for bolt shear, ginagawa natin, kinukuha lang natin yung details ng bolt, ng connection natin, and then pumupunta tayo sa table 7-1. So, for bolt tension capacity, so, paano ba magkakameron ng tension? So, ibig sabihin, yung mismong bolt natin, hinihila natin, pinupull natin yung mismong bolt. At present yan dito sa condition na to. Ito yung bolt natin, di ba? And then, kapag meron kang forces na along doon sa length niya, tendency nito is ma-tension, ano? So, pero hindi pa natin consider yung capacity niya. And according to the code, the same formula applies sa tension capacity. Parehas lang sa shear. Okay, which is Rn, F, and AB lang din yung gagamitin natin. Pero for this case, gagamitin natin nominal stress is yung base dito sa tensile strength natin. Yung before ginagamit natin itong nominal shear na to. And then once we have calculated that, we try to compare it with the table that we have, which is table 7-1. So ganun din sa tension, may table din siya. And I will provide you the copy of that later. Pero that is yung table 7-. Okay? So table 7-2, medyo straightforward siya. Unlike kay shear, di ba, i-define natin kung ano yung condition ng threads, siya ba ay single or double shear or single shear. Pagdating kay tension, ano lang siya, identify mo lang yung group, then kung ano yung diameter niya, makukuha mo na as is yung capacity ng bolt natin. So wala siyang kino-consider na shear plane kasi since tension nga yung loading natin, walang effect si shear dun sa tension capacity ng bolt natin. Kaya papansin nyo, si table 7-2 is much simpler and straightforward than table 7-1. Kasi nga 7-1, we need to be careful in selecting whether our thread is included or excluded, tapos kung double shear ba siya o single shear siya, bago natin ma-identify yung value ng capacity. Again, for bolt tension capacity, kailangan lang natin is yung designation niya, whether A325, A490, A307, or group A or group B siya. And then we identify the value of the diameter, and then whatever is needed, we have 3/4, tapos group A, yun na yung value agad ng capacity. Okay? So, straightforward din siya. So, kung pinapakuha yung total tension capacity, bolt tension capacity ulit natin, kasi pagkakuha mo ulit nito, bawat yung nakuha natin value, that is the tensile capacity ng bolt, kip per bolt. So, to get the total, you just need to multiply it by the total number of bolt dun sa connection natin para makuha natin yung total capacity niya in tension. Okay? So, that is bolt tension. And then, when both tension and shear are present doon sa bolted connection natin, yung bolt capacity is typically calculated by considering yung combined effect ng dalawang loading na yun. So, katulad nga nitong sample natin dito, we have a WT na nag-act siya, na applied with an inclined loading. Okay, so pwedeng i-check natin yung capacity ng connection na to based from the following limit state. Yung una, i-check natin siya doon sa bolt shear capacity niya. Okay, so ibig sabihin, kailangan natin kunin yung component nitong 60 kips based sa horizontal at vertical niya. Okay? So kung halimbawa, itong horizontal pinag-uusapan natin load, ito yung ating bolt. Ano yung horizontal? Anong tawag doon sa horizontal natin? Is that shear or tension?
Tension po.
Tension, of course, kasi ito yung bolt natin iniila natin. So that is tension. And then, or yung component niya downward, that is, shear off natin tong bolt natin dito, no? Yung area ng bolt natin, shear off natin. So that is our shear. Okay? So to consider daw the effect o yung interaction ng mismong dalawang loading natin, which is tension and shear, again, check natin yung limit state ng bolt shear capacity, bolt tension capacity, and yung tinatawag natin interaction between the two forces. So ano daw yung interaction between the two forces na yung sinasabi, So, tests have shown na yung strength daw ng mga bearing fasteners subject to combined shear and tension resulting from externally applied forces can be closely defined by an ellipse, according to Kulak et al. In 1987. So ito yung graph na nire-represent kapag you have combined loadings acting simultaneously sa connection natin. And as based dito sa graph na to, if we have full tensile load na applied, ito yung capacity natin. Halimbawa, zero yung shear, tapos meron kang full tensile load, ito yung capacity natin. Or halimbawa, meron tayong full na shear, pero zero yung tension, iyon yung capacity natin. Pero ano daw yung nangyayari kapag may portions ng loading natin ay shear and then yung iba ay tension. So, ang representation niya is an elliptical shape daw or curve na syempre in our side, kapag pag medyo iba na ang shape, we tend to have difficulty na, especially kung ellipse na siya. Kaya sabi ni Code, pasimplihin natin ngayon yung consideration niya and nag-plot siya ng equivalent na straight line dun sa elliptical na behavior kapag meron ng combination ng loading natin ng tension at shear. Okay? So, ang sinasabi ng ating simplified na graph is kapag ang loading natin, whether yung shear at yung tension natin is within 30% or halimbawa, meron tayong tension, tapos kinompare natin with shear. Si shear is less than 30% ng tension natin. Ang sabi niya, we don't need to consider yung effect ng shear. Okay? Or walang masyadong effect si shear dun sa tension capacity natin. Okay? Yun yung sinasabi dito na hanggang 30%. Ganun din kapag halimbawa meron tayong shear and then yung value ng tension natin is wala pang 30% ng value ng shear, it means na wala siyang effect dun sa capacity natin. Okay? So, ang gustong sabihin, para malinaw lang sa atin, ano? Ang gustong sabihin, if the shear load is less than 30%, yung interaction natin is neglected. Hindi mo kailangan kunin yung reduced value ng shear natin. Kasi halimbawa dito, titingnan nyo dito, ito yung hanggang 30%, ano? Pero pag halimbawa, yung shear natin, dito tayo tumingin sa shear, ano? So dito, hanggang dito yung 30% lang ang shear. Ito yun, no? Ito yung abscissa ng sa shear. Kapag halimbawa yung shear natin is lumampas na dito, baba, di ba? Lagyan natin ng drawing. Ito yung sa 30% ng shear. Okay? So, halimbawa yung shear mo nandito na somewhere dito. Okay? Mapapansin nyo, pag pinlat nyo, yung shear mo, nandun, ito na lang yung kaya niyang ito na lang yung kaya niyang tensile stress dito. Okay? So, ibig sabihin, reduce na yung value ng tension. Ibig sabihin, yung iba nun is gumagana na para sa shear and then yung capacity ng iba, nung tensile mo, nababawasan na kasi lumalaki na yung value ni shear. Okay? Same with dito sa kabila, pag pinagbaliktad naman natin, halimbawa, ito yung ating tension na 30%. Kapag halimbawa ang tension natin is nandito, sa portion na to, pagtas titingnan natin yung ating shear capacity, papansin nyo na yung value ng shear capacity natin is lumiit na din siya. Okay? So, yun yung effect niya. Kaya nga, kapag para ma-consider natin na merong interaction yung dalawa, if yung value ng shear load o tension load is less than 30%, neglected natin yung interaction. Pero pag lumampas siya ng 30%, ibig sabihin may effect daw, nare-reduce na yung capacity niya sa shear or sa tension. Yun yung gusto sabihin ng curve. Okay? And ito yung formula na yon na sinasabi sa interaction equation. Okay? Pero natin to, gagamitin natin yung binigay ni Code mismo. Ito nakalagay naman pala, no? When the required stress is less than or equal 30% of the corresponding available stress, the effect of combined stress need not be investigated. So, ibig sabihin, kapag less than or equal 30%, kahit hindi mo na i-check sa interaction, dito ka lang sa bolt shear capacity lang, tsaka sa bolt tension capacity ka lang. Hindi mo kailangan ng bolt interaction capacity. Okay? Pero pag greater than 30%, aasahan mo na yung value ng yung capacity mo sa shear at sa tension will be reduced dahil nagtutulungan na yung dalawang loading to resist yung combined loading natin. O yung nagtutulong na yung capacity ng connection natin to resist yung combined loading applied to it. Okay? So, paano natin makukuha yung reduced na stress? Ano? So, i-base na lang natin dun sa tension. Kasi same lang din naman with shear yun. Ano? So, considering si tension, yung modified tensile capacity daw natin will be as follows. So, ganun pa din naman yung ating resistance o yung ating capacity, that is just yung stress times area. Pero kailangan natin makuha yung value ng modified stress natin. And ang modified stress natin is given by the formula na ito. Okay? So, saan nanggaling to? Itong 1.3 FNT minus ito. This is actually based from the slope nitong straight line natin dito. Okay? So, nagkameron ng 1.3 doon. Okay? Kasi halimbawa, kinuha natin yung intercept nitong line na to. Okay? So, babalikan nyo ang analytic geometry nyo. Mag-intersect yun dito somewhere, pag pinlat natin na ganyan, mag-intersect yun somewhere dito. Kung ito yung full FNT, this is somewhere 1.3 FNT. Okay? Kaya nagkameron ng value na FNT dito, 1.3 FNT, minus, ito is yung slope ng mismong line natin, multiplied by small FRB. And ang meaning nun, applied factored shear stress o yung required shear stress natin based from overload combination. So, mamaya i-discuss natin through example na lang paano kinukuha tong FRB, small FRB. Ano? Itong FNT tsaka FNB, this is can be taken from table J3.2 natin. So, puntahan lang natin yung table J3.2. Makukuha natin yung value ng FNT tsaka FNB. Yung phi natin, since this is combined loading ng shear and tension, so ang phi natin is 0.75 para sa LRFD, and then ang omega natin is 2.0 para sa ASD. So, same lang yung formula natin dito nagbago lang kasi since dinidivide natin kapag safety factor, kaya nandun siya sa taas, and nandito minomultiply natin dito sa capacity ng shear. Okay? And then, compare natin tong equation na to with FNT lang. Okay? So, kung yung makukuha natin value na modified, multiply lang natin by the area ng bolt, makukuha natin ngayon yung risk capacity natin. And then, saan natin ko-compare ito? Since binase lang natin sa modified tension capacity, i-compare natin ngayon yung makukuha natin siya with, compare to capacity natin ng tension, TU, dun sa TU natin. Okay? So, yung ibig sabihin ng tension dito, kung ano yung value nitong TU na to, dun mo siya i-compare dito. Kasi nireduce natin yung tensile. Kung gusto mo halimbawa, shear naman yung reduce mo, you will still apply the same formula, babaguhin mo lang tong FRP. Babaguhin mong FRT. Okay? Pero hindi na natin kailangan gawin yun kasi nga, we will focus on this equation. Okay? So, let's have an example problem to demonstrate how to use yung equations natin and how to check whether our given connection satisfy o can sustain yung interaction ng combined loadings natin. Okay? So, we have here a WT 10.5 by 31 is used as a bracket to transmit 60 kip service load with W14 by 90 coulomb. Okay, so the load consists of 15 kips dead load and 40 kips live load. 4 7/8-inch diameter group A bolts are used. The column is A992 steel and the bracket is A36. Assume all spacing and edge distances requirements are satisfied. Analyze this section or this connection based on combined loadings. Okay, so i-check natin whether kaya nung capacity bolts natin yung effect ng combined loadings natin. Okay? So, to start with this problem, we need to identify syempre yung given natin. And the first given that we can utilize is of course yung applied loadings natin. Kapag meron tayong applied loadings, we can calculate yung ginagamit natin for design, which is yung calculate natin yung ultimate load natin. Calculate natin si PU. Okay, so we have PU is equals to 1.2 ng dead load plus 1.6 of live load. So, substitute natin, we have 1.2 times 15 kips for dead load, then 1.6 times yung 45 kips per live load. Okay, so upon calculating, so 1.2 times 15 plus 1.6 times 45, we have 90 kips. Okay? So, ito yung ating ultimate load. So, sabihin dito, ito yung 60 na total ng dead load at live load, di ba? So, ito yan din yung ating PU. Ilagay natin dito. Okay, so along that line, yan yung ating PU. Okay? So, kung may PU tayo na incline, pwede natin makuha yung ating tension tsaka shear force. Paano natin kukunin yung tension at shear force natin? Based from our diagram.
Yung sa slope po.
Sa slope, ano? So, we have a PU dito. So, lagay lang natin dito. Ito yung PU. Meron siyang 3, 4, and ang hypotenuse niya is
5 po.
5, no? And then ito, meron siyang component. Ito yung kanyang TU. Ito yung kanyang VU. So, let's calculate yung value ng TU tsaka VU based dito, no? So, we have, paano makuha si TU? Ano magiging formula natin? That is
4/5 po.
4/5 ni PU. Correct, ano? So, 4/5 times yung PU 90K, ano? So, for those who are wondering paano naging 4/5, ratio and proportion po tayo, no? So, ito, no? Over to equals yung hypotenuse o yung PU over 5. Tapos, pag inano mo, ipakita na nga natin for the benefit of everyone. So we have TU over PU is equals to 4/5. So, cross multiply lang, that is 4/5 PU. Okay? So, we have 4/5 times 90. So, that is 72 kips. Okay? So, kung, ayan, next is yung VU natin. Ano ngayon yung magiging VU natin?
3/5 PU.
Okay, so 3/5
3/5.
PU. So, we have 3/5 times 90 kips. So, that is how much? That is 54 kips. Okay? So, that is our first step. So, in-identify natin ngayon yung shear and tension loading natin. Okay? And then, how many yung ating bolts? As mentioned dun sa problem, we have how many bolts? Ilan yung bolt ng connection natin?
4 po.
So, we have 4 bolts, ano? So, ibig sabihin, yung 4 na yun, they will be sharing yung value ng TU at VU individually, ano? So, we can get actually yung capacity per bolt. Okay? So, calculate loading per bolt. Okay? So, yung number ng bolt natin is nakalagay ay 4 na 7-inch. So, 4. So, para makuha natin yung TU per bolt, okay, so that is TU over NB, or that is 72 kips per 4 bolts. So, yung value natin is 72/4, that is 18 kips per bolt. Kips per bolts. Okay? Next, we have yung VU per bolt. So, we have VU over NB, that is 54 kips all over 4 bolts. So, that is 54/4. That is 13.5 kip per bolt. Okay? So, why do you think kailangan natin kunin yung value niya per bolt? Ano yung reason behind it? So, ito, ba't kinukuha natin to? Number bolt. Kasi di ba yung kunin natin sa table 7-1 tsaka sa 7-2 are all loads based sa per bolt na value, ano? Kaya, convenient na i-represent natin to. Okay? So, there's a question, neglected by yung self-weight member sa dead load. So, for this problem, neglect siya, ano, kasi in-include niya na 60 kip, 15 kips yung dead load. So, neglect na niya yung dead load dun sa analysis nito. Okay? So hindi din natin kasi alam yung length mismo nung member WT kung ano yung ginamit niyang length. So hindi din natin makukuha yung pinaka-dead load ng mismo material natin. Okay, next. So, meron na tayo ito na capacity. So, ibig sabihin, ito yung kinakarga, 18 kip per bolt o 18 kip yung kanyang tension per bolt and then 13.5 kip per bolt yung kanyang shear. Yan yung na-experience siya, yung applied loading sa kanya. Okay? Ngayon is to calculate, di ba kailangan kasi natin i-check later dun sa interaction equation natin. We need to calculate yung value na tinatawag nating FRB. Okay? So si FRB, ang definition niya, applied factor shear stress or yung required shear stress para galing do sa load combination natin. So kung siya ay stress, automatic, alam natin na ang formula ng stress ay
Load over area po.
of course, load over area. So anong loading yung consider natin? So that is So kasi kailangan natin yung VU, okay? Over anong area yung gagamitin natin? So syempre area nung bolt natin. Okay? So dito ayan, kunin natin ngayon yung FRB natin. So gawin natin step 3. Calculate FRB. Okay? So sa FRB may dalawa tayong possible solution sa kanya per equation. Yung una, FRB is equals to yung shear natin per bolt over sa area ng single bolt lang. Okay? Or FRB is equals to dun sa shear natin over para makuha natin yung FRB, that is kung ilan yung number ng bolt times yung area ng bolt natin. Okay? Pero since meron tayong data ng BU o yung value ng shear natin per bolt and then yung area ng bolt, madali nang kunin. Ito na lang gamitin natin first one. Okay? So to calculate FRB, that is equals to, yung VU natin per bolt is 13.5. Okay? Ito yun, VU, 13.5 kip per bolts. And then we have AB. So, ang bolt natin is a 7-8 inch diameter. Okay? So, area ng bolt, so area ng circle lang naman yun, pi over 4, 7, 8 inches yan, squared. Okay? Tapos yan ay area per bolt, per bolt. Kaya dito sa equation, magka-cancel yung per bolt. Ano magiging unit natin for this?
Kips per square inch po.
Or that is
KSI po.
ASI, correct. Okay? So ito yung value ng FRB natin. Okay? Yan. So may FRB na tayo. Now, we can proceed with checking ng mga limit state natin. And again, tatlong limit state yung check natin. We have yung sa bolt shearing, bolt tension, o bolt tensile capacity, and then yung bolt interaction capacity natin. Okay? So let's start with bolt shearing. Bolt shear capacity. Okay. For bolt shear capacity, anong kailangan natin details? So, alam natin yung diameter ng bolts natin, 7/8. Tapos, balikan natin yung problem. Anong type ng group tayo? Meron tayong group A na bolts. Okay? Group A yung bolts and then hindi sinabi kung excluded or included. Okay? Pero ang ginagawa natin, ano ang safe assumption natin? So, group A tayo. And then, ano yung thread condition natin?
Included po.
Included, or N. Tapos, ano yung ating shear? Shear plane natin. Ito yung
Single
ating
shear.
connection. Single shear lang siya, no? Kasi makikita naman dito, ito lang yung nasi-shear off sa kanya. Okay? Isang area lang nung bolt natin. So, ito lang yan. Okay? So, single shear lang tayo. So, balik lang naman to doon sa ginagawa natin. And, pag meron na tayo nito, anong ginagawa natin? Pupunta tayo ng table 7-1. Okay? So, open ko lang yung table 7-1. Okay. So, this is table 7-1. So, we have group A. Thread condition natin is N. And then, 7/8 yung diameter natin. So, ang capacity natin per bolt is 24.3. So, VRN, V, lagyan ko ng sub na V, ano, is 24.3 kip per bolt. Okay? So, yan yung sa ating shear capacity. So, let's go back to sa slide. So, saan natin ko compare yan? Yung na-calculate natin yung value na yan. Yung nakuha natin from the table. Yung 24.3. Of course, dun sa applied natin. So, meron tayong applied na BU per bolt. Okay, yung shear natin per bolt. Ang value natin ng shear per bolt is 13.5 kip per bolt. So, anong masasabi nyo ngayon dito? Ito yung ating capacity ng bolt natin. Ito yung applied sa kanya. So, anong magiging conclusion natin sa kanya?
Kaya po ng bolt.
Ibig sabihin, kaya ng bolt. So, since VRNB is greater than sa VU natin per bolt, therefore, okay tayo sa shear. Okay? Sabihin, kayang-kayang kargahin ni bolt yung shear load na applied dun sa ano natin, sa bracket natin, no? O dun sa naka-attach sa column natin. Okay? Next, calculate natin yung bolt tensile capacity natin. So, sa tension, ang reference naman natin, table 7-2 naman tayo. Wala pa kayong copy ata ng 7-2, no? Pero kailangan lang natin again is kung what type of bolt. We have 7/8 inches. And then kung anong group lang siya. Group A tayo. So, share ko yung 7-2. Okay, so ito yung itsura ng table 7-2. So, papasin nyo, tingnan mo lang yung ASTM designation. So, we have group A. For 7/8, ang capacity naman niya, 40.6. Okay, so we have phi Rn sub T is equals to 40.6 kip per bolt. Okay, and then, compare naman natin siya ngayon sa applied tension natin per bolt. Kaya nga, very convenient na kinuha na natin yung per bolt na value earlier para direct comparison agad tayo with the capacity of each bolt based sa shear tsaka sa tension natin. Okay? Balik lang natin dito. Ayan. So, ito yung capacity na nakuha natin. So, ang ating TU per bolt is equal to 18 kips per bolt. Okay? So, since yung VRNT natin is greater than do sa TU per bolt, or ibig sabihin, yung capacity natin in tension is greater than dun sa applied loading natin, it means kayang-kaya suportahan yung tension load natin, yung connection natin. So therefore, this is okay. Okay? So a little note lang, if either nung shear o nung tension is mag-fail, ano, or maging less than sa value ng ating applied loading, it means hindi mo na kailangan mag-check ng interaction, ng bolt interaction natin. Okay? O hindi mo na kailangan kasi nag-fail na sa isa, it means fail na din siya doon sa interaction natin. Okay? Pero since so far, okay pa tayo sa bolt shear capacity and also sa bolt tension capacity, we can proceed with the bolt interaction capacity natin. Okay? So punta tayo sa number 6. Calculate natin yung bolt interaction capacity. Okay? And sa bolt interaction capacity, we need to get yung value ng reduced value ng tension stress natin. So F and T is equals to minimum between yung equation natin is yung mahaba equation natin isa yun, ano? Yan, ito yung equation natin. So, copy ko na lang to. Okay, so dito okay. So ito yun. So kailangan lang natin muna i-identify yung FNT tsaka FNB natin. So yung FRB, na-calculate na naman natin yan kanina, no? Ang na-calculate natin value is 22.45 KSI. Ito na yan. 22.45 KSI. Okay? Si FNT at FNT tsaka si FNB, titingnan natin sa table J3.2. Tama ba? Let me check lang. Tama. Table J3.2. Okay? So, ito po yung itsura ng J3.2. Nabigay ko na po ito sa inyo last time. Okay? Ayan. So, J3.2, nominal strength of fasteners and threaded parts. So, yung bolt natin is group A. Okay? And then, ang assumption natin, included, ano? So, not excluded yung atin to. So, dito tayo sa column na to. So, ang value ng nominal strength natin, o FNT, is 90. Sulat ko lang. FNT is equals to 90 KSI. And then, ang FNB natin is 54 KSI. Okay? So, once you have that, you just have to substitute it dun sa equation natin and then solve for whichever is minimum dun sa given natin for equation, ano? Okay, wait lang. Naglo-load lang yung screen. For a while. Okay. So far ba may question or may clarification? Okay naman do sa FNT at FNB natin, ano? Ayan. So, going dito sa value na to, so substitute lang natin. So, we have minimum of 1.3 times FNT natin is 90 minus 90 over phi natin is 0.75 times 54. Ano yung value niya? Times FRB. FRB natin is 22.45. Adjust lang natin to. Okay, so ano yung value niyan? And then FNT natin is 90. So pag kinalculate yon 1.3 times 90 minus 90 over 0.75 times 54 times 22.45. So 67.11. Okay, so minimum is ito. So therefore, ang ating reduced value ng FNT is equals to 67.11 KSI. It means na dahil meron tayong meron tayong combined loading, kumbaga dapat 90 yung gagamitin natin value na capacity. Since meron tayong shear, naging 67.11 na lang yung usable na shear natin. And with that value, we can calculate the reduced capacity natin for tension or yung base sa combined interaction natin. Ano? So, para makalculate yun, so we have Rn is equals to F prime NT AB. Okay? So, yung Rn, yung capacity is 67.11 KSI, so kip per inches squared. And then, area ng bolt. So, ang area ng bolt natin is again pi over 4 times 7/8 inch squared. Okay? So, kung ito lang yung multiply natin ng number ng bolt, ibig sabihin yung makukuha natin unit is capacity niya for kip per bolt. Kada isang bolt, ibig sabihin kasi 1 bolt lang yung gagamitin natin. Okay, na mas convenient naman sa atin kasi i-compare na lang natin siya dun sa tension capacity o yung tension loading per bolt natin, which is 40.355 kip per bolt yung value niya. Okay? So, yung kanyang VRN will therefore be 0.75 times Rn, 0.75 times 40.355 kip per volt. So, VRN, so times 0.75 lang. So, that is 30.266 kip per volt. Okay? So, ito yung reduced capacity natin. Ngayon, i-compare natin with TU. TU from the previous slide is 18 kip per volt. Okay? So, since that is later, therefore, safe or okay din. Okay? So, ang pinaka-conclusion natin, connection is adequate. Okay? Kasi, pumasa siya dun sa lahat ng limit state natin or shear, for tension, tsaka for combined loading or yung interaction natin ng capacity. Okay. Question po dito. Question. Para saan po kayo yung 60K sa illustration? Yung 60K is yung total nung 15 at 45. Ganyan yung na-represent to sa problem eh. Actually, you can check yung book ni Segi. That is actually solved in Segi's book. So, sige, i-double check natin yung kay Segi. Ano, baka iba yung answer niya. Ito yung kay Segi. That is example 7.10. Okay? Ito yan. So, dito, ayan daw, figure 7.30. 7.30 ay nandito sa taas. Yan, ito yan, 7.30. So, yun talaga yung figure niya. No? And then, yung example niya, tingnan natin yung mga na-solve niyang value. For PU, yan, 90 kips. So, parehas lang sa atin. And then, ayan, ito yung mga comparison niya. Yung bearing strength, hindi na natin chinek yung sa bearing, ano. Pero sa shear, chinek natin, that's okay. And then, for tensile strength, of course, we calculated sa 18. And then, ito yung FRB niya, 22.45. Then lastly, ayan, yung pinakahuling na-calculate natin, which is yung reduced capacity natin for tension, which is 30.3 lang yung nakalagay sa kanya. Sa atin is 30.266 yung nakuha natin value. Kinompare natin with 18. So, okay. Ibig sabihin, connection is adequate niya as a bearing type connection. Okay. Question pa po?
Kailan po sir hindi ko na-consider yung combination ng dalawa?
Kapag halimbawa, ayan, good question ano. So let's go back dun sa mismong ano natin, slide natin. Then let's look at the value nung mismong loading natin. As 'di ba ginawa natin, we consider yung value nung shear tsaka nung tension natin. And as you can see, nakuha natin value for shear is how much ngayon? And yung value for shear and value for tension. Okay? So wait lang ha. So pag nakuha natin yung sa shear, di ba yung sa shear nakuha natin 54 kips. And then yung tension natin 72 kips. Compare din yung dalawang value. Halimbawa si shear kay tension, di ba more than 30% siya. So since nag more than 30% si shear do sa value ano ba 30% ng 72. 30% ng 72 ay 21.6 lang. Since nag-exceed ng 21.6 yung value ng shear, it means we need to consider yung interaction o yung combination ng loadings. Yan yung tinatanong ko sa Elwin. Ano? Kailangan ko consider yung combined loadings or interaction once na nag-exceed ng 30%. So yun yung sinasabi ko kanina na once the loading or the value of your tension or shear exceeds 30% of one another, it means you need to consider interaction. Kapag less than or equal lang sa 30%, you don't need to consider yung bolt interaction and then just check yung capacity niya based sa shear, based sa tension, and then based na dun sa other checking natin before like bolt bearing, tsaka yung depende kung bearing type or slip critical connection yung meron tayo. Question pa? Hindi na bumabalik dun sa slide, ano?
Pero kapag po ba nag-fail na po agad dun sa isa, example po, tensile po or shear, ano na po ba may conclusion na nun?
Hindi adequate yung connection mo. So, kung papadesign sa inyo, edi kukunin mo yung loading and then pabalik tayo dun sa design step natin for connection ng bearing type or slip critical na ginagawa natin before na kukunin natin yung S-mean tapos LE-mean and then magta-trial tayo ng mga connection layout na pwede. Basta regarding with your question, kapag bumagsak na siya ng shear checking pa lang tsaka ng tension, you don't need to check for interaction anymore kasi nga bumagsak na siya. Kaya ang conclusion mo na agad, connection fails or inadequate yung connection. Tapos kapag inasa problem na you will be tasked to design or to provide a connection na kayang i-resist yung loading natin, and then babalik ka dun sa step na pinag-aralan natin before for bearing type connection and slip critical connection. Okay. Other question? Okay. So if none, that ends our lecture for today.